Hello there, our wonderful and esteemed viewers. You are welcome once again to our favorite mathematics YouTube channel, Mathematics by Abu Zainab. That special channel created for you and I to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Today's class promises to be interesting and fun as usual, as we take the last lap on the topic surd. In our previous videos, we've introduced what the concept of surd is all about. We've looked at the various operations of surd, which include addition, subtraction, multiplication, and lastly, division. And in our last video, precisely, we dealt extensively with the concept of division of surds, which essentially involves eradicating the square root at the denominator by a process called rationalizing the denominator. And of course, we explained that we have two categories there. We have the monomials and the binomials, which was solved using the concept of conjugate. Today, we are looking at an extension of that division, particularly the conjugate aspect of it, by looking at the concept of equality of surds. When exactly are two separate surds equal? By comparison, when you say one surd on the left hand side equals to the other on the other side, it simply means you are comparing term by term. Without wasting much time, sit back and let's have fun. We have two examples on the board to explain exactly the concept of equality of surds. Basically, let's take example 1. We have 3 plus 4 root 2 over 4 minus 3 root 2. This is pretty much like the last lesson on the division of surds. So without wasting much time, we adopt the concept of multiplying the numerator and denominator by the conjugate of this denominator. The conjugate, if you can recall, is 4 plus 3 root 2 over the same 4 plus 3 root 2. So we simply expand both numerator and denominator. For the numerator, don't forget our expansion. We have 3 here plus 4 root 2, multiplying 4 plus 3 root 2. All you need to do is by picking each term, in this case 3 first, to multiply the contents of the next bracket. When we are done with that, we now pick 4 root 2 and repeat the same process. So we go 3 times 4 is 12. Then 3, the same 3 times 3 root 2. That's 3 times 3. 9 root 2. So I'm done with 3. I now move to 4 root 2 to repeat the same process. So 4 times 4 then is 16 root 2. Now 4 times 3 is 12. And root 2 times root 2 is 2. So you have to be meticulous in each step. For the denominator, however, if you recall from the last lesson, when you multiply a conjugate or conjugates, is akin to using the concept of difference of two squares for the expansion. So you have 4 minus 3 root 2 times 4 plus 3 root 2. Simply put, is 4 squared minus 3 root 2 squared. Don't forget, we are adopting the difference of two squares there. So we have then 12 plus 9 root 2 plus 16 root 2 plus 12 times 2 is 24 over 4 squared is 16 minus 3 squared is 9, root 2 squared is 2. So collecting like terms there for numerator, that's 12 plus 24 plus 9 root 2 plus 16 root 2 over 16 minus 18. So basically, when we add up like terms, that's 36 plus 25 root 2 over minus 2, which is pretty much the solution. However, because of the fact that we are asked to express in the form n plus n root 2, meaning we are separating, whereby you have an n standing alone and an n as a coefficient of root 2. So by separating here, we are going to have 36 over minus 2 plus 25 also over minus 2 root 2. Which finally becomes, because minus 2 can go in 36, that's minus 18, then plus divided by minus, minus 25 over 2, then root 2. So this exactly is pretty much like writing in the format m plus n root 2, where n there, by comparison, m is minus 18, and n, who is the coefficient of root 2, is minus 25 over 2. And that basically is the end of the solution to question A. Without much time wasting, let's go straight to question B. B might seem to be a bit daunting, but trust me, it's not as scary as appears once you start solving. So let's go. For question B, however, we are told outright that 5 minus 3 root 3 over 3 plus 2 root 3 minus 3 minus root 3 over 3 minus 2 root 3 is equal to A plus B root 3. All we need to do now is to find exactly the values of A and B. So we have 5 minus 3 root 3 over 3 plus 2 root 3. Then minus 3 minus root 3 over 3 minus 2 root 3. What you need to do, is to either solve one by finding the LCM, which is preferable anyway. You can either solve this separate and this one to separate and subtract. That's one approach. Or I take the LCM directly, which I prefer anyway. So the LCM here is simply 3 plus 2 root 3, then bracket 3 minus 2 root 3. That's LCM. So we go 3 plus 2 root 3, we cancel 3 plus 2 root 3. Then we have 3 minus 2 root 3 left. Times this, we have 3 minus 2 root 3, bracket 5 minus 3 root 3. That's for the first part. Then minus, similarly, 3 minus 2 root 3, we cancel 3 minus 2 root 3. We are left with 3 plus 2 root 3 multiplied by that. So we have 3 plus 2 root 3 multiplied by 3 minus root 3. So by going further, I will simply expand the numerator. So we have 3 by 5, 15, then minus 9 root 3, now minus 10 root 3, then plus 6 times 3. So I have 3 times 5, 15, 3 times minus 3, minus 9 root 3. I'm done with 3. Then minus 2 times 5, minus 10 root 3. And minus times minus is plus. 2 times 3 is 6. Root 3 times root 3, 3. I keep that. Minus, let me open the bracket. I'll do the same here. 3 times 3, 9. 3 times minus root 3, minus 3 root 3. 2 times 3 plus 6 root 3. Minus 2 times minus 2 times minus 1 minus 2. Root 2 times root 3 is 3. Again, to be double sure, 3 times 3, 9. 3 times minus root 3, minus 3 root 3. 2 times 3, 6 root 3. 2 times minus 1, minus 2. And root 3 times root 3 is 3. Luckily for us here, we have conjugates again here. We have 3 plus 2 root 3 times 3 minus 2 root 3. That simply means 3 squared minus 2 root 3 all squared. And for the numerator, I'm going to have 15. Like times now, 6 times 3 is what? Plus 18. Minus 9 root 3. Minus 10 root 3. I'm done with that. Minus, I still have my bracket. Then have 9. Minus 2 times 3, that's minus 6. Then plus 6 root 3, minus 3 root 3. All over 3 squared is 9, minus 2 squared is 4, root 3 squared is 3. So I have 15 plus 18 is 33. Minus 9 root 3 minus 10 root 3 is minus 19 root 3. I want to believe you are still following me. So minus 9 minus 6 here is 3. And 6 root 3 minus 3 root 3 is plus 3 root 3. Divided by, I have 9 minus 12. So here, I have now, I can then open the bracket there. So I'm going to have then minus 3 minus 3 root 3 over 9 minus 12 is minus 3. So at this stage, I can now collect like terms. 33 minus 3. That's 30. Look at that. 33 minus 3. You don't have square root. Now, minus 19 root 3 minus 3 root 3. That's minus 22 root 3 over minus 3, which is pretty much the solution. However, we are told explicitly to express in separate terms. I'm going to have 30 over minus 3 minus 22 over minus 3 root 3, which becomes minus 10 plus 22 over 3 root 3. So in conclusion, find the values of A and B. We just compare A with B minus 10, B being the coefficient of root 3 is plus 22 over 3. And that is pretty much the end of the solution to question B as well. And of course, the end of the lesson for today, which has been equality of surds. As you can see clearly, is deeply based on a very good understanding of rationalizing surds, precisely using the concept of conjugate surds. As you can see in mathematics, math is like chain. When there's a breakage somewhere, you most certainly are going to have issue later on. That's why we can't take things for granted. Mathematics, any topic you need to learn in mathematics, make sure it is thoroughly learned, because this might be your undoing in future. So, and that's the end of our lesson today, and the end of our lessons on surd, basically. I hope you understand the topic and enjoy this video much as I did. If you do, please don't forget to share. Recommend to those who need it. You might not need it, but those who need it really. Recommend to them, share, subscribe, and most importantly, put on your button so that you'll be the first to know when our next video is uploaded. Stay tuned and stay blessed. Thank you.